Hi, I'm Andrew Gillis with Sepro Mineral Systems. This is a short video explaining why gravity separation is done as a wet process rather than a dry process, explaining some of the fundamentals behind this. So let's have a look at Stokes' law here. And what Stokes' law does is, in this form, show the terminal settling velocity for a particle. And the things that make this up are the gravitational force, the size of a particle, this is its radius squared, the density of the particle, and this is the important part when we're talking about the difference between water separation and air separation, for example. We've got the density of the fluid, and we've got the dynamic viscosity of the fluid. So basically the resistance to movement in the fluid is represented by this term. And in this formula, for a heavy particle and a light particle, these things, gravity, the density, the diameter, can all remain the same. And between air and water, these are the terms that are going to vary. So let's take a look at how these can, what happens when these vary. So here I have the fluid density, but also baked into this equation are changes in the fluid dynamic viscosity between air on this end and water on this side. So what you can see here is that the velocity of a particle, and for example here I've got a pure copper particle and a pure mineral particle, as the density of the fluid and the dynamic viscosity increases, the terminal settling velocity in that fluid of these particles drops dramatically. And this is a log scale. So up here we've got 1,000 meters per second, and down here we've got 10 meters per second. So the take-home point from this graph is that in this range of around, say, 10 meters per second, give or take, operation of a process becomes much easier. If you're trying to exploit density differences between a particle for separation, and you're having to deal with velocities around 1,000 meters per second, one, that's an extremely difficult process to operate, and two, there's going to be very high wear, especially when you're talking about mineral particles traveling at 300 meters per second in any sort of piece of equipment. There's going to be extremely high wear. So for low wear and ease of process operation, reducing the particle velocity is very important. In addition to that, we've got the relative difference in the terminal velocity between in this case, a copper particle and a mineral particle. So in water, that relative terminal velocity is about 3.3 times higher for a similarly sized copper particle. Whereas when we're using water as a fluid, that relative velocity goes up to roughly 4.7. So these increases in relative velocity between the heavy particles or the dense particles and the light particles also makes separation easier. And to the extent that even more viscous fluids can be used, so if you have a lot of, let's say, very fine particles in the fluid and it creates an artificially dense medium, and the density goes even higher, this gap will widen and the relative velocities between those particles will become greater and separation will become easier. So fundamentally, that's the reason that wet separation is used rather than dry separation or air processes when it comes to effective particle separation, and especially for very fine particle separation when you have similarly shaped particles. Wet processes are of course, the standard in the mining industry and have been for several hundred years, and now in IBA, incinerator bottom ash separation, especially for fine metal separation, wet processes are becoming adopted routinely now for the separation of particles.